Number 15, in right triangle RST, okay, one angle is of 90 degree. The sum of the measures of R and S is 90 degrees. Angle R and angle S is 90 degrees. So that means if RST is a right angle triangle, one angle is of 90 degree. So now data is showing us that R and S, sum of this is 90 degree. So that means third angle T is actually the 90 degree angle. So that means this triangle is right angled at T. So sum of R and S is 190 degrees. It's by angle sum property, right? If I consider like angle T plus angle R plus angle S is equal to 180 degree, which is the angle sum property. R and S is 90 degree. So angle T plus 90 degree is equal to 180 degree. And angle T, subtracting 90 on both sides, I get angle T is equal to 90 degree. Also, if R plus S is 90 degree, that means angle R and angle S both are acute angles. Okay. One point is clear. This is concept 1. We have taken angle sum property and and it shows that angle T is 90 degree. Now let's leave it here and learn the second concept. Concept 2. I'll take one more time this triangle, the same triangle. Now, when we talk about trigonometric ratios, theta is never at right angle. It is at one of the acute angles, right? So suppose if theta is at R, so then it is the side which is opposite to it, right? So if it is theta is or the considered angle is at R, in that case opposite is TS and adjacent is RT, right? This is the theta, so this RT is touching it. And hypotenuse is the side which is opposite to 90 degree. That is never changed. So in that case, hypotenuse is RS. Now what if theta is at T? So let's draw another triangle. Oh, okay, sorry, theta is at S. I'm sorry. So R, theta cannot be at T at right angle. So if theta is at S, in that case, opposite is RT. This is the main concept in trigonometry, right? We generally make mistake at this point that where the theta is, opposite and adjacent are considered accordingly. So here opposite is RT and adjacent is TS. See, here they have changed places. Here opposite is TS, adjacent is RT. Here opposite is RT but adjacent is TH. But hypotenuse is always the same because right angle is never the theta and this RS is the side here in this triangle which is opposite to 90 degree. Concept number 2. Concept number 3. Let's leave it here. And concept 3 is sine theta, cos theta and the tan theta. These are three trigonometric ratios. So sine theta is opposite over hypotenuse. Cos theta is adjacent over hypotenuse. And tan theta is opposite over adjacent. These are the three trigonometric ratios. And theta, again, according to concept, depends upon which theta is at which angle, so sides may change. Okay, three concepts done. Concept 1 is to find the right angle. Concept 2 is actually what is the meaning of opposite and adjacent, and concept 3 is what are the three basic three T ratios: sine theta, cos theta, tan theta. Now Let's do one more concept. Concept 4, right? If I say 3 by 4 or 6 by 8, these are like equivalent fractions. So if two sides of the triangle are 6 and 8, I can say that these are in the ratio 3 is to 4, right? So ratio is always the standard form. It is not the actual measurement of the sides. If the sides are 6 and 8, two are in this ratio, I will say ratio is 3 is to 4. So these three are ratios, right? Not, it does not mean that, for example, in our question, it is given sine r is equal to root 15 by 4, right? So it is given sine r is equal to root 15 by 4. So, and sine r is actually opposite over hypotenuse. So it does not mean that opposite is of the length root 15. It is, maybe there is a common multiple with root 15 as well as with 4, the same, but we are taking the ratios, right? And we have to find the ratios. So we will just for the sake of simplicity, we will take the measurements and opposite as root 15 and hypotenuse as 4. Okay, let's see what is the question. So sine r is given and cos s is asked. Okay, let's draw triangle one more time. So here is the triangle. Here it is R, it is S and T, and in the question it is given sine R is equal to root 15 by 4. Now if we see concept 2 and 3, right, you can just pause it here, go back and see the concepts, or you can write them on the paper. So if it is R, opposite is TS, right? So sine theta is actually opposite over hypotenuse. So opposite is root 15 and hypotenuse, which is opposite to 90 degree, is 4. That is given to us. And cos S is asked. Let's see what sides are used in this for cos S. But if we need the third side, we can use Pythagoras to calculate the third side. But let's see, is it needed or not? So yes, if it is T, it is S and it is R, right? Theta is at S. Cos theta is what? Adjacent over hypotenuse. Adjacent over hypotenuse. So now if you see the triangle, right, this is root 15 and this is 4. So for cos S we need TS, which is adjacent. They have interchanged. So that is root 15 and hypotenuse is 4. Now we have done it with a very simple method, like without knowing any complex formulas, but and we are, we understood this method, that's fine. But there is one formula, I just want to mention it. If you want to do it that way, that's also fine. We have complementary angle properties, right? The complementary angle property is sine theta is equal to cos of 90 minus theta. That is a complementary. See, this method is totally option if you do not want to do that, but I just want to mention, right? If you need some kind of shortcut or something, or some complex identity, so sine theta is equal to cos of 90 minus theta. Now angle R plus angle S is equal to 90 degree, that is given. So angle R is equal to 90 degree minus angle S. So angle S is equal to 90 degree minus angle R. So theta can be any. So if one of them is theta, other is 90 minus theta, right? So if I say sine of R, so that is equal to cos of 90 minus R. So sine of R is equal to cos of s. So if we know this property, right, then we do not have to do the concepts we have done before, and we can directly apply this property. Okay, sine r is going to be equal to cos of s. So no need to do anything else because this is what is asked in the question. But if you don't want to learn so many properties, so at least we can go quite easily with this question by very simple concepts, by very general and simple concepts, right? So I hope that is clear.